What up? It's Mr. Roach here for you. It is February 13th. I'm recording this ahead of time because I'll be gone today during class. Quick lesson here on writing some equations. As always, make sure you are respectful to the sub, that you're respectful to each other, and that you're getting your work done today. See if you can get out of here with no homework. And if you do have some extra time, clean up that grade book, make sure you got no missing work. Use this time to be productive going into a long weekend. When you watch videos in here, I always encourage you to pause and try the problem yourself, especially as you're starting to feel comfortable with it. See if you can beat me to the answer, and a good way to do that is to pause the video. Then you can always rewind or slow it down if you need to. We're trying to write equations today. Pretty short lesson, and then like I said, good amount of work time to end our school week. The daily problem today is going to have you graph a couple of equations. The biggest thing that we need to look at here is what information do we get from y equals k times x. That's our typical format. Y equals k times x. What information is given to us? This is a proportional relationship. So as always with proportional relationships, we're going to start at 0, 0. And like I said, I would encourage you, if you haven't already, to pause the video and see what you can come up with. How would you graph this? Quick review of what we did yesterday on Thursday in class. So like I said, proportional relationships, always starting at the origin, always starting in the middle at 0, 0. This is our slope. Our equation gives us our slope. It's kind of just written out there. Sometimes students are like, oh, I don't like that it's written as a fraction. I think that those are even easier because 2 is my change in y, also known as your rise, and 3 is your run. So how much am I going to go up? How much am I going to go across? So I'm starting at the origin. I'm going up 2 and across 3, and wherever my pen stops, that's where my point is going to go. I'm going to do the same thing, go up 2 and across 3. There's another point. We talked about this yesterday, that you can make this guy kind of go in the opposite direction by remembering a negative divided by a negative is still a positive. So negative 2 divided by negative 3 is the same exact thing as positive 2/3. So I'm going to do the backwards directions where I can go down 2, that's a negative y movement of 2, and then left 3, that's a negative x movement of 3, and wherever my line, my finger, my pen, whatever, stops, that's where you're going to put your next stop. Cleaning up my scratch work there because I don't need it in my final line. Go down 2 and across 3. And I've got a proportional relationship graphed. If you don't have a fraction, like in this one, make it a fraction. So negative 4 as a fraction would be negative 4 over 1. There should be a nice negative going down from left to right. A reminder with negative slopes, either the top is negative or the bottom is negative, but not both. Never, ever both. So we're going to start at the origin just like before, just like all proportional relationships. I'm going to go down 4, that's only 3. I'm going to go right 1 because my run is positive 1 on this orange guy. And there's my next point. I'm going to go down 4 from there. I'm going to go right 1. There's my next point. And if I follow this red pattern, I could do the opposite and go up 4. Change in y is positive 4 would be right there. And then left 1 would land me right there. So go up 4, 1, 2, 3, 4. Go left 1. And wherever I stop, there is my dot. And I've got a nice negative slope going down from left to right. We put this in words early in this unit, like a submarine or a whale is diving down, maybe 4 meters per second or whatever have you. That'd be pretty fast, but hopefully you get the idea. Trivia question today, another time that you can pause and try it for yourself. There was a government agency that is still around today that was originally started to stop counterfeiting. See if you can make a guess. No penalty for wrong answers. It is the Secret Service. The Secret Service was originally founded to stop counterfeiting. I don't know if they still do that or not, but now their main job is protecting the important people in our country. Here's a quick quiz for you. Not really a quiz, but a quiz for you. One of these is proportional, one of these is linear. See if you know why. What's the difference in their graph? How can I tell by looking at a graph that something's proportional or linear? The answer is the origin. This guy goes through the origin, which is why it's proportional. It does have a very clear unit rate, like this is up 3/1 every time, up 3/1, so that also helps. This guy does have a unit rate. It's the same exact unit rate, up 3/1, up 3/1, but it doesn't start at the origin. This is the biker who had a head start. We're going to come back to this, so keep this in your brain. We're going to talk about equations with a head start later on. If I'm looking at a table, I need to make sure that that constant growth is still there. So this one decreases by 2/3, decreases by 2/3, decreases by 2/3, add negative 2/3. So that guy, you've got negative 6/3, which is -2. And I'm seeing 0, 0, so this is proportional. This one I can rule out right away as not proportional because of that. And also I don't have a consistent growth. I add one, and then holy cow, I drop all the way to -8. That's kind of weird. So 2 reasons why that's not proportional. Gross. Now we're going to spend a lot of time with this guy. Proportional relationships have an equation that is almost copy-paste every single time. The one thing that's going to change is K. K stands for the slope or the constant of proportionality. You also might hear teachers talk about this as M. M is another way to say slope. But why we use K is guaranteed to be a proportional relationship. We use K when I know it goes through the origin, when I know it's got an even, steady rate. Like this one, if I wanted to find the slope, the change in Y, let me erase this stuff. The change in Y, say from here to here, is down 2. Now you might be asking yourself, Ms. Roach, why did you pick those 2? Because they're the easiest. You can pick whatever you want. Just pick something that looks really easy. And I'm going to match it on the X's. Here's my run. My run is +3. My change in Y, my rise is -2. So there's my slope. And going back to this slide, if I want to use that in the equation, the only thing I have to do is replace the K with -2/3. Going back up here, I said, hey, we're going up 3/1, up 3/1, up 3/1. Well, once I know the slope, I'm going to take that slope and replace the letter K with it, and I'm done. So really the work here is to find what the slope is. As we start to look at some of these problems, some of these word problems, my job is to find slope, and once I know it, right there, replacing K, we're always going to see Y equals, we're always going to see X. It's just that format every single time. I like these ones because they just kind of write it out for you. Given a slope of 4, I don't really have to do a lot of work because it just told me my slope is 4. Write an equation for a proportional relationship. Well, I'm going to use that same format, but now K is 4. A line that goes through the origin is proportional. And now this one has a slope of 3/5. Fractions are totally fine for slope. Y equals 3/5 X. In fact, I like fractions better because that's your rise and that's your run. Easy peasy. This one, another way to say proportional, goes through 0, 0. If the slope is -10, well then Y equals -10 times X. You just slide that number in, replace K, and you're done. Now, problems, of course, won't always be this easy. We have some different formats for you, right? I might not just give you the slope. You might have to work for the slope. Here's one way that we can make it a little bit challenging. We've seen these number problems before, and I have to change my brain to find the rise between the Y's and the runs between the X's. Pause really quick. See if you can do this. We've done a couple of them. Don't expect you to be perfect, but give it a try. Hopefully you remembered alphabetical order for coordinate points. Kind of a weird thing. My slope goes Y then X. My coordinate points go X then Y. So this guy starts at 0 and goes to 6. That's my change of Y right there. increase by 6. My change in x, I start at 0 and I go to 3, is a change of 3. So my slope here would be 2. I don't know if you can see that very well. But it asks me to write an equation, right? That's the prompt of this problem, write an equation. Really just have to replace that k value with a 2. Y equals 2x. And if you were to put this on, say, Desmos, like this, if I typed in y equals 2x, I've got a proportional relationship. There's 0, 0. And up here, I don't know if I'll be able to stop on it exactly. I had it for a second. There you go, is 3, 6. So it's the exact line, just in a different format. Let's do a couple more. I'll show you one more way to do this. A lot of times students just like to kind of inspect it and say, hey, my y's here are increasing by 2. That's my rise. My x's are increasing by 1. Oh, that's actually the same line. Same equation, same everything, same slope. Slope is 2. Equation is y equals 2 times x. Now, this can get a little tricky when we throw in some negatives at you. So I'm going to show you this formula one more time. It is written on the whiteboard, kind of in the middle on the bottom. It's in purple in my room if you're in there right now. Sometimes we subtract the y's, would be a good way to find the change in y. And we can subtract the x's to find the change in x. You'll notice that I'm using y2 and x2, y1 and x1. It's just saying, okay, this is point 1. That is the first point that I know. So I'm going to call this guy x1 and y1. This one I'll call point 2 is x2 and y2. It doesn't really matter. You could make this one y2 and x2 if you really wanted to. You just have to be consistent, right? If I'm calling this point 2, it needs to be point 2. And those numbers need to come first. If I decide to call this one point 2, then those numbers have to come first. But I usually just go in the way that it's written. Just makes it a little bit easier for me. So I'm going to say y2 minus y1, 2 minus negative 1 is my change in y. x2 minus x1 is my change in x. Top 2 minus negative 1 is positive 3. On the bottom, 1 minus 2, you can keep change if that's helpful for you, would be negative 3. So my slope here is negative 1. So again, trying to find the slope so that I can write an equation. You can use this strategy on all 3 of these problems if you wanted to. You can also just ask yourself, okay, well, what would it take for me to get from negative 1 to positive 2? So you can do either strategy for all of these. It doesn't really matter. I think this one sometimes is easier with negatives. You're just doing a quick subtraction problem. My equation here, plugging in my slope for k, would be y equals negative 1 times x. We've got a couple more to do here, just some different representations. Now I don't have words, I have a graph and a table. Still the same game, I still gotta find slope. With a graph, pick any 2 points as long as there are nice legitimate points like this one. I can see that that one hits 9 perfectly and hits 3 perfectly. And I could pick this one, or I could pick this one, or this one. You could even go down into quadrant 3 if you wanted to. It doesn't matter how big you make your triangle. It doesn't matter what 2 points you pick. It'll all give you the same answer. So if I pick those 2, the vertical part of that triangle is my change in y, is 1, 2, 3, 4, 5, 6. I go from 3 to 9 is a change of 6. My x's start here, change 1, change 2. There's my run. My slope is 3. So here comes my equation. Just plop 3 in for k. Y equals 3 times x. I'm using this format every single time. Tables work pretty similarly. I need to know how much is my y changing. How much is my x changing? My rise and my run. Pick any 2 points. It doesn't really matter where you look. If I just go from here to here, my x's are also going to go that box. If I decide to go bigger, because I want to be a crazy person and go all the way down, that's fine. Your x's are just going to go all the way down too. So just pick 2 very consistent ways of looking. Usually the box right next door is going to be the easiest one. My y's increase by 3. Or 6, sorry. They increase by 6. Geez, Mr. Roach. My x's increase by 4. Kind of a weird slope, but we can still work with it. 6/4 simplifies to 3/2. While I would like that bottom number to be 1, it doesn't have to be. Improper fractions are okay. Y equals 3/2 times x. I would not change that to 1.5. I would leave it as 3/2. It's pretty easy to graph. I go up 3/2. So there's my equation. Okay, you give it a try here. I've got 3 quick problems. Pause the video, try these 3, write an equation, and then resume, and we'll talk about it. First one is a word problem. We need to find the slope for Emily, who bought 6 ice cream cakes for $48. That seems like a steal. And it tells us, if we read ahead a little bit, the total cost is going to be y, and x is going to be the ice cream cakes. So she is paying $48. That's her rise. For 6 ice cream cakes, that's her run. 48 divided by 6 is 8. Pretty much the unit rate is $8 per ice cream cake. My equation, y equals 8 times x. This is what we're looking for on these problems. A graph, the poor sloth is kind of being picked on here. It can go 6 feet in 1 minute. So you got to be careful about your scales here, because the x-axis goes up by halves, not by ones like normal. So that is my unit rate right there. I go up 6 and over 1. My slope is 6/1. My equation, y equals 6x. If you said 3, you probably said that this was 2. Totally understandable. On a test, I probably wouldn't mark that wrong, to be honest with you, just because we switched the scale on you down here. This one's a little bit trickier. I'll remind you that alphabetical order is best with tables and points. So the top is going to be x, the bottom's going to be y. My change in y from any box to the next is 30. My change in x from any box to the next is 2. Slope, rise over run, is 15. So my equation, y equals 15 times x. Bam. One more page here and then I'll be done recording. Just kind of looking at some of these, we're going to start talking a little bit deeper about different types of equations. And there's one more type of growth that we study a little bit in this unit. I think picking out the proportional relationships sometimes is easy and sometimes not so much. This guy, for example, those are the equations that we have been writing almost all video here. Y equals 4 times x. But sometimes our equations can get a little bit jumbled. Like, look at this guy. X and y are together. I don't want x and y together. We almost always want y by his lonesome. So how would you move this x to the other side? I'll give you a hint. When they're squished together like that, they're multiplying. So to move it over, instead of multiplying by x, I'm going to divide by x. On the right side, I have y alone. And on the x side, or the other side, I have 12 divided by x. That's close, but it's not quite. I need that number times x. So this one, not proportional. Look at right below that. This is another one that almost looks proportional. This is an inverse relationship. We want to see k times x. and this is k divided by x. That is not proportional either. This one, top right, looks close. Make your guess if it's proportional or not. It looks so darn close. This is the biker who had a 3-meter head start. So this one has a slope, that's your K, but he had a 3-meter head start. This would not hit the origin. This is a linear relationship. This is a graph that looks like that. 2 more for you here. Both of these are proportional. So look at this guy. If I want to get y alone, always like y alone, instead of doing y divided by x, I could multiply by x and multiply by x. Over here, those x's cancel, and I've got y equals 24 times x. That is proportional. This one, your slope is 1/2. It's kind of a tricky one. Y equals 1/2 times x. They just multiplied 1 and x, right? They did that fraction multiplication. The biggest thing that you will need to be able to do is be able to determine when does it have a head start so it's not proportional. And then you'll have to differentiate between, oh, am I dividing by x or am I multiplying by x? Dividing by x, not proportional. Multiplying by x, definitely proportional. We'll keep working on that as we go through the week. This is just a quick little intro. Have a great rest of your Friday. Be respectful to each other. Be respectful to the sub. Make sure you're asking good questions and getting your work done. Mr. Roach is out.